Welcome to part 3 of this series. One of the advantages of working procedurally is that you can create dynamic setups that will adapt to what you have in the scene. Point in case, we currently have 4 primitive objects connected to the switch node and they show up in here randomly. Let's say you want to add a 5th object. So let me put in a platonic solid and I'll connect it to the switch node. And let's make this an icosahedron. So when you look at it, you don't see anything really changing. And the reason is that currently what is pushing the selection is what we wrote either in our attribute wrangle or in the attribute create node, and it's this number over here. So we set 4 objects and we hard-coded the number 4. If I change that to 5, you'll see now that the platonic solid is showing up. Same thing if you do it with the attribute create. If you go down to the value and you change this to 5, and then you connect that to the for each, you'll see it work again. So that's great, but it's forcing you to actually hard code the values. What if you want to create a system that does it automatically for you? So I'm going to cut this platonic solid again, and I'll show you how we can do that through the switch node itself. So the first step that we're going to do is we're going to add a new input parameter. And for that to work, we're going to go in the switch node to the little gear up here on top, and we're going to edit the parameter interface. That's going to bring us to this window. We're going to add an integer into the root. And the reason I'm adding an integer is because the number of objects obviously are integers. We cannot have floats in there. So let's call this total number. And for the label, we're going to call this total number of objects. Okay, we'll just leave it as is. One thing that you do want to have is in the range, lock the 0, and then this number can grow dynamically as well as long as you keep that unlocked. Okay, so click on apply and accept, and we have in here this new parameter. You see here we can shift it. Now the key to this is actually putting in a command called opn inputs. So type opn inputs, and we're going to reference it to itself. So open parentheses, open quotes, put a period, close quotes, close parentheses, and do that. Nothing happens yet because we have to take this information and drive it to our parameters that actually calculate the random aspect. So we're going to put our cursor in here, right click, and copy parameter. And then let's start with the attribute create first. You're going to go to the value, and then instead of multiply times 5, which is a hard-coded, we're going to right click and we're going to paste relative reference. So it's actually pasting the channel that we have, which is from the switch, and this is the name of that parameter. Okay. So now if you set this platonic switch, you'll see that it automatically updated, and you can have as many as you want. So I'm going to copy that. Let's change that to, let's say, a Utah teapot. Put that in, and you'll see that it updated the number of elements going into the switch. You can actually see that if you go back into the switch node itself and you click on the actual parameter name, and you'll see here that number. So currently we have 6 objects that are going in. If I remove these 2, you'll see that it changed back to 4. So that's actually pretty cool. And if you want to do that in the attribute wrangle, again, you can go in here, you can copy this whole line, go to the attribute wrangle, and let's paste it instead. Have an extra parentheses, and there we go. So if you connect that to the for each, it will do that as well. And if you take both of these and connect them, you'll see that it updates on the fly. And again, you can check by going to the total number of objects, and you see that it shows you the proper number of objects that are going in. In this next bit, I'm going to show you how we can randomize the objects on our grid, but this time without using the attribute wrangle or the attribute create. So for starters, I'm going to select both of them, and I'm going to bypass them by clicking on the little yellow arrow that you see in here. So that brings us back to the switch, selecting the first object, which in this case is the tube. We're going to apply the randomization directly on the switch. Now, before we do that, I want to ensure that you all have this metadata node in your for loop. If you don't have it, the way to access it is by clicking on the for each begin and clicking on this button that says create meta import node, and that's going to bring that up. What this node does basically is it counts and shows you the iteration that the for loop is going through and the total number of iterations, and you can access this information if you go down to your geometry spreadsheet. And if you look here where my cursor is, you'll see that you have point, vertices, primitives, and then this last one is the details. So when you have this node selected and you look at the details, you'll see that you have two options. So iteration, this is the current iteration that it's on right now, and the num iterations, that's the total number of iterations. So we're going to use this in order to get our switch to actually pick a random value for our objects. So to do that, I'm just going to jump back into the switch again, and we are not going to be using the point command anymore. What we're going to be using is a combination of a few commands. So we're going to use the fit01, the random, and the detail command, and that's going to allow us to get all those objects. As well, I'm going to incorporate our open inputs as we had in here, but rather than have it on a separate parameter, I'm going to put it inside our select input. So for starters, I'm going to disable this. So I'm going to press Control Shift and left click. And I'm just going to, before I jump in, I'm just going to give you a little bit of information about the commands that we're going to be using. The first command that we're going to use is the fit01 expression, and basically it fits a value to the 0 to 1 range. So if you have any number, you can assign a new minimum and a new maximum to replace the 0 to 1 default. The other command that we're going to use with the metadata node is the detail function, and that returns the value of a detail attribute. So as we mentioned before, the metadata in the for loop returns detail attribute, and we're going to use that for our purposes. I'll start by getting rid of the current information that we have in here, and I'll type out the command and then go over it with you in the expression editor. So if you see now on the screen, everything went back to being randomized. So let me go over this information again with you. So we have the fit01, and that's going to take basically this number, and it's going to give it a new minimum and a new maximum. We're using the random value of the detail from the metadata. So this whole section in here actually calls the metadata node and goes over each one of the iterations. And then we're going to start at entry point 0, which is the first object in our switch. And then the open inputs is going to calculate however many objects we have in total, and it's going to feed it in. This effectively creates a similar effect as we did before when we used the attribute wrangle and entered this value. So as you can see in here, we have some randomization happening with our objects. Something else that we can try is to get some variety in terms of the randomization of the objects that we see in place in here. Every time that you run this command, you're going to see the same set of order for all your objects. What we can do is replace this parameter and turn it into a random seed and feed that random seed inside of our select input. So let's go back to our edit parameter interface. And what we're going to do is get rid of the total number of objects that we had originally. So I'm just going to delete it. And instead, I'm going to throw in here a float. So I'm going to call this float for its name as random seed. For the label, random seed capitalized. And for the range, I'm going to set it between 0 and 10. I'm just going to leave it as is. So apply and accept. So now we actually have this little slider that goes from 0 to 10 with decimals. So what I'm going to do is I'm going to take this information, I'm going to right click on it and copy parameter. And then in here, it's going to move forward until I put my cursor between these two parentheses. Okay, I'm going to put a plus and then right click and paste relative reference. Okay, so you'll see that it added ch and then the name of the random seed variable. So now if you grab this random seed slider and you start moving it, you'll notice over here that the objects are now being placed in a completely random order. To wrap this up, we're going to add finally the random rotation and scaling to each one of the objects. And the way that we're going to do that is we'll use an attribute wrangle again to give us that kind of control. So I'm going to leave the original ones that we created in here, and I'm just going to drop another one. So attribute wrangle, connect it. And I'm going to introduce you to a couple of really useful commands. The first one is the @pscale. And what this one does is it scales every point in the object. So in this case, it's going to scale and give we're going to give a random value to the points on the grid. So you're going to set @pscale equals, and we're going to set it, let's say, between a value of 0.3 to 1.5. You can change those numbers to anything you want, but for this example, I'm just going to use those two. So again, I'm going to use a fit01 command. So fit01 rand, and we're going to do it on the point number. And then we're going to set it between 0.3 and 1.5. Don't forget to put a semicolon. So once you click out, you'll notice that the objects are now completely randomized in terms of their scale. And again, as you change these values, so let's say if I make this 3, oops, go back here. See, it really scaled them up. Let me go back to what I had before, not that far back. Redo, there we go. Another command that's really useful, another parameter rather, not a command, that's really useful to know that will allow you to change this is the @orient. So we'll do the same thing. I'm going to put an @orient, and this is going to affect the rotation. So we're going to randomly rotate it. So I'm just going to put a rand @ptnum. So now each object is going to be randomly rotated on its own axis. Okay, so that's great. So we have a random positioning, and over here we have a random scaling and a random rotation. You can add even a little bit more of control over it and change by creating another seed generator. So I'm just going to go to the vex expression, just drop it a couple of lines, and I'm going to create a slider that's going to let me control that seed. So the attributes that you see in here, the p-scale and the orient, when you click on them, you'll see that they show up. You set it to points. They show up in your geometry spreadsheet. Okay, so you see here the scale and the orient. But for the seed, we want to keep it internalized inside our vex expression. So for that, I'm just going to use a variable. It's going to be a float. So I'm going to type float seed equals and do a channel float, so CHF, and I'm going to call it seed. So whenever you type this command CHF or CHI if it's an integer, and you click on this little slider icon over here, it's going to create a slider for you that you can then move around and get values from it. So what I'm going to do is I'm going to use this variable called seed, and I'm going to add it to my point number so it can give me additional variations on it. So I'm not going to add it, I'm going to multiply it. So let's press times seed. And let's see what that does. So now if I take the slider and I move it, you can see that it's randomly scaling the object. So if you look at this sphere, for example, over here, as I slide the slider, see it goes from all the parameters that we set between 0.3 and 1.5, whatever random value it receives. One thing that you'll notice though is this very last one, or rather this very first one. As I move my slider, you'll notice that all of them change except for that one. And the reason is that the point number starts at 0. So if you multiply something by 0, you still get 0. So there's no change. The one way to fix it is when you go to this ptnum, you put a -1 in front of it. And now as I move it, it will also change its scaling. You can do the same also using that same seed. You can also add it to your rotation if you want, which could be really interesting. So again, you can go to ptnum and you can multiply it by the seed. Okay, so orient equals ran at ptnum times seed. So when you move the slider, you'll see that your objects are scaling and rotating at the same time. And if you go back to the switch and you click on the slider for the random seed, you have a whole variety of settings that you can use for your objects. And then you can, again, keep on adding, subtracting objects, and it will always calculate them properly. So I hope this was useful for your future project, so you can scatter a whole bunch of things randomly on a surface. And we'll continue with this lesson where we'll do scattering, but more of an art-directed scattering rather than doing it on a grid in our next lesson.